Good morning, everybody. So we are going to do two more examples about solving systems in context, but these are inequalities. And please pause the video and read this paragraph. Hopefully you did that. So we've got Alexa here, and she has two jobs, and the two constraints are the amount that she's working and the amount of money that she gets. It says that she has to work at most 15 hours per week, and she wants to earn no less than 260. So this at most and no less, these words, we have to really think about them, be careful. At most 15 hours. So that means she can work 15 hours, but she cannot work 16. She can't work anything more than 15. So she has to stay less than 15 hours, or she could be exactly 15 hours. With the money, no less than $260. What does that mean? Could she earn 250 or could she earn 270? Which one would work? She wants no less than 260. So in other words, she wants at least $260. All right. Well, for the hours, she has our variables. X is the number of hours of tutoring, and Y is the number of hours of landscaping. So I can write X, which is the total number of hours for tutoring, plus Y, the total number of hours for landscaping. That has to be less than or equal to 15. Because she can only work a maximum of 15 hours. For the money, however, she gets $22 per hour. So there's that word per again. So we're multiplying. 22x is all the money she gets from tutoring, plus 13y is all the money she gets from landscaping. So if I add those two up, that's all the money together. And she wants at least 260. This would be exactly 260. This would be more than 260, but this is at least 260. And then these are our two constraints. So we need to graph both of these. So to graph these, it's best to put it in y equals mx plus b form. So for this one, I would just have to subtract x on both sides. And I discover that the y, so in other words, the number of hours of landscaping has to be less than the opposite of the hours of tutoring plus 15. For here, I have to do two things. I got to subtract 22x, and then I have to divide by 13. And then dividing this by 13, I need my handy dandy calculator. 22 divided by 13, they don't go into each other evenly. So my best is negative 22 thirteenths, but 260. 13 goes into 260 exactly 20 times. So I've got my two equations. Now I need to graph that. So the first one was negative 2x, I'm sorry, negative x plus 15. And this is very nice. I could just press plot and it'll graph it for me. But my inequality, is my inequality correct? I needed y to be less than negative x plus 15. So I switched this to less than or equal to. And then now, this is, if any ordered pair on this line would be exactly 15 hours of work. Any values above it would be more than 15 hours. Any values below it would be less than. So we have to shade that part. She needs to be at most 15 hours. The other one was negative 22 thirteenths x plus 20. And that was greater than, because this is the money equation. Sorry, the money inequality. So any ordered pair on this line, for example, this ordered pair is 3, 15. So if she does 3 hours of tutoring and 15 hours of landscaping, she will make exactly $260. But she wants at least 260. The more the better, right? So we want y to be greater than. So I see the way it's shaded now, it's under that. So all the green, she would be making less than 260. So I switch the shade again, and that's more than 260. Now, I'm sure she would love to make all this money way over here. So if she did 18 hours of tutoring and 20 hours of landscaping, she'd be making more than 260. But it's past this constraint. So she would also be working more than 15 hours. So for this worker, only the double shaded region is her solution. This allows her to work less than 15 hours, but at the same time make more than $260 per week. So any ordered pair in here. And notice this word could. So there are many, many solutions. We just need to find one in this region. And I'll just pick this one, 13, 1. So 13 hours for tutoring, 1 hour for landscaping. And we got it right. Our second and final example is about Oliver. And please pause the video and read that paragraph. I very much hope you did. Now, how many constraints are there? This says the number of inequalities is 3. It always defaults to 3. So don't, there could be 1 constraint or 2 or 4 or 5 constraints. But the previous example that we did with the tutoring and the landscaping, there were only 2 constraints: the amount of time, the amount of days that she could work, the amount of hours that she could work, and the amount of money that she needed. So there were only 2 constraints. So how many constraints are there here? And what are they? What are they? There are, in fact, 3 constraints. She cannot work more, or he cannot work more than 12 hours. He can earn no less than $90 a week. And he can work no less than 4 hours washing cars. Those are the 3 constraints. So we're going to have three inequalities. Now, what are they? Work no more than 12 hours. X is the amount of hours he spends washing cars. Y is the amount of hours he spends clearing tables. So which scenario talks about that he can spend no more than 12 hours? Waiting for my pen to load. It is this one right here. This is the X plus Y has to be less than or equal to 12. This is the one that, this is the inequality that we need. This one over here is saying that he has to work at least 12 hours. So this is a kid from the 19th century when there were no child labor laws. If you were, 9 years old, you were working 60 hours a week or something. So this one over here is 12 hours is the most that he could work. So we reject that one. What about the second constraint? He can earn no less than $90. $7 per hour for washing cars, $10 per hour for cleaning tables. So if you add those up, that's all the money that Oliver gets. So is all the money that Oliver gets, do you want that to be under 90? Or do we want all the money that Oliver gets to be more than 90? He wants no less than 90, so we want it to be more than 90. So we're going to get rid of that guy. 7x plus 10y has to be at least 90. And lastly, no less than 4 hours washing cars. Which one of these represents no less than 4 hours washing cars? Well, first of all, we can get rid of the y situation because y represents the amount of hours clearing tables. So x is how many hours he spends washing cars. Do I want that to be more than 4 hours, or do I want that to be less than 4 hours? And it says no less than 4 hours. So I don't want it to be less. He wants to, in other words, he wants to spend at least 4 hours washing cars. Boy, that guy loves cars. So here are your 3 constraints, and you're going to graph all of them. So to graph them, you put them into mx plus b form if possible. This one is not possible, so this is just a vertical line. But the other 2 are. So you would subtract x. The slope is -1, not -1x. The slope is just -1 with a y-intercept of 12. And here the slope is -7/10 with a y-intercept of 9. And now we graph. So 3 constraints. Inequality number 1, I forgot already. Y has to be less than or equal to -x plus 12. So y is less than or equal to -x plus 12. Plot that. This is the time, the amount of time that he works. So any ordered pair on this line, he is working exactly 12 hours, and he needs to work 12 hours or less than that. So I shade under here. Obviously, he could work 0 hours, right? That's less than 12. The second inequality was -7/10 x plus 9. So this was a y is greater than or equal to -7/10 x plus 9. And just to make it interesting, I made it -7/12 for some reason. And this is the money inequality. So any ordered pair on this line, he is making exactly $90. And he wants to make at least $90. So I need to be above that. So far, all the ordered pairs in the double shaded region are good. But there's still one more constraint. He has to spend at least 4 hours washing cars. So x is greater than or equal to 4. And watch the vertical line. Boom. And anything to the left of that, he's spending less than 4 hours washing cars. Anything more than that, he's spending more than 4 hours washing cars. So I need to shade to the right. Now, the triple shaded region is this little triangle right here. This will satisfy all 3 constraints. He's not working more than 12 hours. He's making at least $90, and he's spending at least 4 hours washing cars. So any ordered pair you can find in here would be a solution. And I only see, well, maybe a couple, but one that's for sure is this one right here, which is the ordered pair 5, 6. So 5 hours washing cars, 6 hours clearing tables, and we got it.